AP Calculus AB, this is a review for Chapter 1. We're looking at a couple free response practice problems. This first one, you cannot use a calculator. Consider the function h to answer the following questions. Question A, find the limit of h as x approaches 1 from the right. Show your numerical analysis that leads to your answer and explain what this result implies about h of x. Well, to find this limit, I don't have a ton of ideas. There's nothing to factor up here. You cannot factor an x out of the top because this is the angle. It's an inside function. This term does not have a times x in it. Even if you could, you can't cancel an x minus 1 from the top and the bottom. So what does that tell me? That tells me this has a vertical asymptote at x equals 1. It's got to, because this is a non-canceling factor in the denominator. If we approach 1 from the right, is the graph going to be going up or is it going to be going down? We could probably figure that out. This is a calculator permitted problem. So use a little table. If we approach 1 from the right, that might be something like 1.1. So if I have negative 2x minus sine of x over x minus 1, if I use my calculator, which I'm allowed to do, and I figure out 2 times 1.1 minus sine of 1.1, my top's going to be negative. 1.1 minus 1 is going to be positive. This is going to be negative. So that tells me if I'm approaching this from the right, this is going to be going to negative infinity. Explain what this result implies about the graph. Well, this tells me that h of x has a vertical asymptote at x equals 1. This is a vertical asymptote existence, a theorem that we had. If x is approaching a number and the limit approaches positive or negative infinity, then there has to be a vertical asymptote here at 1. Just 1 second, I gotta plug my computer in before it goes dead. I don't want that. Question B. Find this limit, show your analysis. This is a weird request. We're supposed to find the limit of h times 2x minus 2 as x approaches pi over 2. Well, let's do that. H was, well, let me just cheat. You're going to love this. Hey, I like those apples. Pretty good apples, aren't they? And instead of me writing 2x minus 2, I'm going to factor a 2 out of that. So it's x minus 1. How is that helpful? X minus 1's cancel. Even if they didn't cancel, this is going to work out just fine. That's going to make the algebra here a little easier. So I'm going to have the limit as x approaches pi over 2. I'm going to distribute that 2. So I get negative 4x minus 2 sine of x. Now I'm going to evaluate the limit using substitution. It's going to be negative 4 times pi over 2 minus 2 times sine of pi over 2. Pi over 2 is on the positive y-axis. Sine of pi over 2 is going to be 1. That's weird. So I'm going to have negative 4 times pi over 2. You can cross cancel and divide the top and bottom by 2 and get negative 2 pi. So this is going to end up being negative 2 pi minus 2. Sweet. Number 6. Explain why the intermediate value theorem guarantees a value of c on the interval from 1.5 to 2.5 such that h of c is negative 4. Well, let's see. For the intermediate value theorem to work, function has to be continuous from 1.5 to 2.5. And the only place that this is discontinuous is at 1. That's not on this interval. So 1, h of x is continuous on the interval from 1.5 to 2.5. And I need to figure out what h of 1.5 is and what h of 2.5 is. Since this is a calculated problem, that's going to be easy to do. Just going to put this function h into y1 and then use my table, put 1.5 in for the x value, and I believe that's going to give me negative 7.995. If I put 2.5 in, I believe I get negative 3.732. Does negative 4 fall between those? It sure does. H of 1.5 is less than h of c, which is negative 4, which is less than h of 2.5. So this was part 2. Didn't label that well. Therefore, the intermediate value theorem guarantees a value of c on the open interval, so not including the endpoints, 1.5 to 2.5, such that f of c equals 4. Now to find that value, I have to take this function which was negative 2 times x minus sine of x over x minus 1. I changed the x's to c's, set it equal to 4. Now, using your calculator to figure this out, you got a couple options. What I did was I set this part here to y1, put this part here to y2, and then did second. I'm sorry, it's supposed to be a negative 4. Negative 4. This should be negative 4, which means this should be negative 4. Anyhow, put y1 at the left side, y2 on the right side, do second calculate intersect. If they intersect multiple times, we only care if they intersect between positive 1.5 and 2.5. And I found this to happen at 2.354. You could also add 4 to both sides here, and then from there, figure out where the zeros are. And if there's a 0 between 1.5 and 2.5, which there would be. All right. This next one is no calculator. So let's see if we can figure this out. Got two functions, G is a graph and f is written as a piecewise function. Pictured above is the graph of the function g of x and the equation of a piecewise function defined by f. Answer the following. A. Wow, what is this limit? So this limit, as x approaches 1 from the right, could be written as the limit of g of x, could pull the 2 out to the front, minus the limit of f of x as x approaches 1 from the right, times the limit of cosine of pi times x. Should be parentheses here. Not sure why there aren't. That needs changed. So using some limit rules, I just wrote this in a way that I think is easier to look at. So looking at my graph, as x approaches 1 from the right, y is getting closer to 2. So this is 2 times 2. Looking at function f, as x approaches 1 from the right, 1 is in this interval. So if we approach 1 from the right, it's like putting 1 in here. It's 1 squared minus 3 times 1. And then cosine of pi x as x approaches 1, well, that's going to be cosine of pi times 1. This is going to be 4 minus 1 squared is 1. 1 minus 3 is a negative 2. And then 1 times pi is pi. Cosine of pi is negative 1. So that's going to make this, let's see, we got a bunch of negatives. 3 negatives, that's going to be 1 negative then. 2 times 1 is 2. That's going to be 4 minus 2, which is 2. Show your work applying the properties of limits. We have done that. B, on its domain, what is one value of x in which g of x is discontinuous? Use the three-part definition of continuity to explain why it's discontinuous at this value. Let's see. Looking at this graph, g is discontinuous here at 1. And let's use that three-part definition. I'm going to bring this graph down here so I can see it while I'm doing this. All right, first part. G of 1 is equal to 0, therefore G of 1 is defined. So that works. Part 2, does the limit exist? Well, the limit of g of x as x approaches 1 from the left is equal to 0. But that does not equal the limit of g of x as x approaches 1 from the right, because that's equal to 2. Therefore, the limit of g of x as x approaches 1 does not exist. Therefore, g of x is not continuous I swear, the faster I try to write, the longer it takes me. At x equals 1. Sweet. Part C. For what values of a and b, if they exist, would the function f be continuous everywhere? Let me bring this function down once again so I can see it. All right, so first of all, is this function continuous, this part of the function? Yes, it's linear. Is this part continuous? Yes, it's a quadratic. Is this part continuous? Yes, it's linear. The only places this could be discontinuous is if when this ends at -3, it doesn't line up to where this starts at -3. And when this part ends at 2, it doesn't line up to this part that starts at 2. So the limit as x approaches -3 from the left, which is ax plus 3, would have to equal the limit as x approaches -3 from the right of x squared minus 3x. Likewise, the limit as x approaches 2 from the left, x squared minus 3x, has to equal the limit of bx minus 5 as x approaches 2 from the right. Both of these limits have to be true. And this first one, the red one, that's going to be a times -3 plus 3 equals -3 squared minus 3 times -3. It's -3a plus 3 is 9 plus 9. It's -3a plus 3 is 18. So that's a is -5. This other one, fortunate that we were able to solve these without using a system of equations. We're going to have 2 squared minus 3 times 2 equals b times 2 minus 5. That's 4 minus 6 equals 2b minus 5. That's -2 is 2b minus 5. So that's going to be 3 is 2b, so b is 3 over 2. Cool. That's it for the free response practice.